Hello, editors, authors, and participants joining us from around the world. A warm welcome to the special issue webinar on optimizing human potential, interdisciplinary perspective from the art, science, and technology of learning. I'm Aisha Anwar, the journal's administrator, and it is my pleasure to open today's session. This special issue explores how the interplay of art, science, and technology shapes education, ranging from neuropsychological to social-cultural dimensions. By highlighting evolving practices in design, assessment, and future-oriented paradigms, it calls on educators, researchers, and policymakers to embrace innovative yet ethical approaches that optimize human potential. Before we begin, just a few housekeeping matters. The session is being recorded and will be shared afterwards. If you encounter any technical issues, please email us. For questions, kindly use the Q&A function and direct your questions to specific presenter where possible. The special issue is guest edited by Prof. Stephen Koslin and Assistant Prof. Azilawati Jamaluddin, whose expertise spans learning sciences, educational technology, and interdisciplinary research. Bringing together diverse perspectives from art, science, and technology, they have curated this issue to spark dialogue and inspire fresh approaches to optimizing human potential in education. Tonight, we are also proud to feature contributions from international authors representing Singapore, the Philippines, India, the United States, and the United Kingdom. Together, they will guide us through key ideas and challenges at the heart of this theme. Now, let me give you a quick overview of the program. We'll begin with an introduction of learning, research, and practice by our Associate Editor, Assistant Prof. Azilawati. She will also share perspective on the issue. Next, we'll hear from Prof. Stefan, our guest editor, on dynamic personalized learning, leveraging AI to develop human potential. After that, we'll be hearing from our wonderful speaker, Louis Jure, Feng Chuan Wang, Xiaohan Chao, Imelda Kellen, and Purnima Mudal. Although a few authors couldn't be with us today, the good news is that all articles from this issue are free access for the next 3 months, ready for you to read, share, and cite. The session will conclude with a Q&A segment moderated by our special issue editors, where you'll have the opportunity to hear responses to your questions. Thank you for being part of this important conversation on the future of education and its role to optimizing human flourishing. Without further ado, let's begin the session. Assistant Prof. Azilawati, over to you.
Thank you so much, Aisha, and a very good evening to everyone. Thank you for being here for this webinar on this special issue on optimizing human potential. So let me just pull up my slides. All right, thank you so much, everyone. So again, my name is Azia. To start off, I'm delighted to share some insights about the journal. So as you all know, Learning, Research and Practice, or LRP for short, is perhaps a testament to the dedication and curiosity of scholars and researchers worldwide. So in collaboration with Taylor and Francis since 2015, LRP has aimed to be the premier platform for groundbreaking research that challenges established views on learning. So LRP welcomes both established and emerging research methods, inviting theoretical investigations, empirical studies, and it has been a leader in educational research for quite a number of years now, and it's indexed in Scopus. So if you access the website for a detailed explication of LRP's aim and scope, you will note that the journal focuses on some of the complex relationships between knowledge, learners, educators, and tools, highlighting how these interactions can be supported and enriched. So the journal accepts in-depth case studies, fresh perspectives. So these are central to LRP's mission, with particular attention to the evolving role of technology and learning. So the journal welcomes studies at all levels, from microgenetics to ecological, and even investigations on how learning is shaped by emotions, culture, and collaboration, including case reports that challenge some of the reductionist views in learning that spark collective reflection on unique learning phenomena. So here is a call for papers. If you have research findings, innovations, or insights that can shape the future of education, LRP invites your involvement. So whether you're an educator, researcher, policymaker, LRP provides a platform for you to share your work to serve as a source of inspiration for many of us, a catalyst of change, as well as a bridge between theory and practice. So I hope that together with the LRP team, we hope that you will consider contributing to the journal. So now let me transition into the special issue that Professor Stephen Koslin and I had the privilege to co-edit. It's titled Optimizing Human Potential, Interdisciplinary Perspectives from the Art, Science and Technology of Learning. So this special issue brings together an exceptional collection of research that challenges us to think beyond traditional educational metrics. It is now live on the website and you can access it directly through the QR code on the screen or the URL link provided. And this issue, as you can see, it features 10 insightful manuscripts, each offering a unique lens, whether through AI, cognitive science, learning analytics, developmental psychology, or socio-emotional frameworks to better understand, support, and elevate human potential. And so these contributions speak to not just how we design academic excellence, but also how we design system, tools, and environments that can empower learners, educators, and institutions in a time of unprecedented change. So just before we hear from the authors themselves today, I thought I can set the contextual backdrop about what is human potential and how do different disciplines define and approach it. So let me start off with education. So in what do we actually mean by human potential in the field of education? Human potential refers to the possibilities that human beings are capable of achieving. This isn't just abstract theory. At its core is an educational mission to help each learner develop to their fullest capacity, whether it's academic, moral, intellectual, or creative. It's a recognition that potential is not fixed, but something that can be nurtured through the teachers, the educators, and expanded through, some of our deliberate cultivation, especially within equitable and supportive systems. And you might notice a recurring theme where education sees human potential not just as an individual fulfillment, but also as a pathway for societal contribution, be it in terms of creativity, innovation, empathy, or responsibility. Now, in the field of psychology, from a psychological standpoint, the concept of human potential is deeply rooted in some of the humanistic psychological movement, where it sees individuals as possessing a natural capacity for growth and self-fulfillment, a potential that is often unrealized but always present. So it's not about so much about fixing deficits, but it's also helping individuals to become their best selves through conscious effort, learning, and personal development. And here's my favorite. In the context of neuroscience, human potential is fundamentally about, the brain's remarkable ability to adapt, grow, and reorganize, what we refer to, as many of us know, neuroplasticity. So these include processes like synaptic plasticity, how neurons strengthen and their connections, rewiring of neural networks in response to learning. But again, the concept of neuroplasticity, of growth and potential reminds us that it isn't fixed, as we know that the brain is always capable of change across the lifespan. So naturally, interventions to optimize human potential should consider how we can prime the brain through experience, relationships, and environments. Um, this is an interesting discipline. From an economic perspective, human potential is also not just a philosophical or psychological construct. It is an investment opportunity. So here I'm just citing Professor James Heckman's paper, where he articulates that capabilities are dynamically shaped over time and are shaped by early life experiences, education, and family environments. So if you were to look at the top right chart, so Heckman illustrates how early interventions, and you can see the flow of the chart, how early interventions, especially in preschool years, they yield higher returns on investments than remedial programs later in life. And also, if you look at the bottom right chart, it reinforces this point. It shows the cost efficiency of investing early versus later, especially for disadvantaged groups, a group that I'm personally interested in, which leads to better school readiness, higher earnings, and improved health and later life outcomes. And you can see these compounding effects over the lifespan. So James Heckman has this equation which seeks to emphasize that to maximize human potential, just as an example, We need to invest early, develop cognitive and socio-emotional skills, and sustain support throughout education into adulthood, where the outcome we could expect potentially could be a more capable and productive workforce. But the key takeaway here is this: human potential can be economically productive. So when we invest wisely, especially in the kinds of systems or the environments that nurture learning, socio-emotional development, and construct like executive functioning, we're not only empowering our individuals, but also strengthening societal resilience and reducing inequality. Now, in the context of healthcare, from a health sciences perspective, human potential is also often understood as the capacity to achieve optimal health and function across the lifespan. So you can see this view integrates what we call the physical, cognitive, and emotional dimensions. And the visual here, it shows you the key phases, right, from your growth to your peak and decline, and reminds us that human potential can be extended and even re-optimized through some of the preventive, diagnostic, and remediative strategies. And it reinforced to us that health is not an outcome, but also a platform for developing and sustaining potential. So with that, the definitions from different disciplines, I thought that in the context of, LRP being a Singapore-based journal, I just wanted to kind of like set the context, because for our international friends who might be online today, there's also this national orientation to advance human health and potential in Singapore, where the goal is to drive research that enhances health, well-being, productivity, and learning capacity across the lifespan, from prenatal, early life, through schooling years to adulthood, and where each life has got its distinct focus areas. So in early childhood, the emphasis is on cognitive, physical, and socio-emotional development. During schooling and young adulthood, the focus could be on function and performance, especially using insights from science of learning. And then later life, it's about supporting healthy and meaningful longevity by, some examples could be in terms of detecting and delaying decline. So in the editorial, you might see, if you have accessed the website or scanned the QR code, you might notice that in the editorial co-authored by Professor Stefan and myself, we kind of like conceptualize human potential not as a static trait, but as a dynamic, evolving capacity that's nurtured across time, across systems. So in the editorial, you would see this diagram where it synthesizes multiple disciplinary perspectives to show how potential is both individual as well as systemic. So at the top, you can see human potential defined as the full development of individual capacities. But this development, we recognize that it doesn't occur in a vacuum, because it's deeply connected to two foundational pillars, which is the human capital, the skills, knowledge, competencies that individuals acquire, as well as the economic growth, the collective benefits that arise when human capital is activated, including increases in, productivity, innovation, as well as GDP. And in the center of this model lies holistic health, encompassing physical, emotional, mental, social well-being. And this centrality signals that unlocking human potential isn't just about cognitive skills or economic outcomes. It also requires some kind of sustained investment in well-being, where, they almost create like a virtuous cycle. Enhancing one reinforces the others. And we do hope that, by focusing on some of these constructs, it potentially could amplify the life course for both individual flourishing as well as national prosperity. Okay, so enough of my contextual backdrop. I would like to, now introduce the speakers from the special issue, because we take a rather integrative approach. So the title of our special issue is the Art, Science, and Technology of Learning. And this is where the special issue has got three key themes, organized around three integrative themes on technologies for personalized and neurodivergent learning, the arts, identity, and the effective core of human potential, as well as looking at some of the psychosocial scaffolds for learning and thriving. So earlier I alluded to the fact that we have 10 exciting manuscripts that document how potential is inherently multidimensional. Today, you're going to be hearing from 6 of our wonderful authors. So before I hand it over to them, may I invite you, as you listen, you could possibly ask yourself what struck you when you hear some of these sharings. How does this connect to your own work? And importantly, how can we work together to maximize human potential and support human flourishing? So we look forward to build a science of thriving together. I'll now invite our first speaker, Professor Stefan Koslin, to share his talk on dynamic personalized learning, leveraging AI to develop human potential. Over to you, Stefan.
Hello, everyone. Thank you for that wonderful introduction. Thank you for that wonderful introduction. It was really magnificently well done. It gave us a really broad framework to think about this entire project. So I'm just going to talk about one tiny part of this, which is thinking about how to help people learn more effectively. So we've developed a technique we call dynamic personalized learning, and it's better, faster, and cheaper. Let me explain quickly how. If you want the details, in that paper. So dynamic personalized learning is an approach. The idea is to capture the essence of what makes one-on-one tutoring better than group instruction, as Benjamin Bloom argued so compellingly years and years ago. It's been shown to be much better than group learning. An expert tutor knows what motivates the student, infers what the student already knows, frames new material to build on what the student already knows, adopts the appropriate pace for that student, and can respond to every relevant question. This is a great way to teach and learn, but it doesn't scale. Even if we could find enough qualified tutors, which we can't, we couldn't afford them. It doesn't scale. But we can distill most of the active ingredients, the things that make this so effective, in this interaction by replacing the human tutor with a large language model. That is an AI. In fact, the LLM can know more about the science of learning than most tutors know. That is, enormous amount has been learned from laboratory studies primarily about how learning and memory work. And we can apply that. We can apply it systematically. And in fact, we can endow an LLM with this sort of information that allow it to be extremely effective. And this method scales. It's remarkably inexpensive, actually. So the way we've developed this technique we call dynamic personalized learning, it's dynamic because it adjusts in real time to the learner's responses and provides immediate feedback. It's personalized because it bases examples, analogies, and exercises on learners' individual needs, preferences, and interests. So in every one of our courses that we develop, we give a questionnaire in advance. We ask people about their interests, their hobbies, ideal vacations, favorite movies, all sorts of stuff. And the AI then draws on that to personalize examples, analogies, and so on. Plus, it's keeping track of how easily they're learning, how difficult things are, so adjust the pace. So it's not so slow as to be boring. It's not so fast as to be frustrating. It's right in the middle, the Goldilocks spot. AI does that really quite effectively. It's very personalized. And then learning, as I mentioned, we draw on the science of learning. We've got a set of summaries of basic principles of science of learning that the AI always draws on to make learning effective, efficient, and engaging. Always is drawing on that in the background. So the way we've set this up is synchronous interactions that are done asynchronously. So it's kind of dynamic asynchronous. The AI is doing debates, it's doing role-playing games, it's doing a lot of things like that that are very interactive, but at a time and place of the user's choosing. So it's the best of both worlds. It's got a lot of synchronous in it, but it's done asynchronously. The large language model teaches via learning objectives and associated rubrics. So every session that we've set up has a learning objective and a rubric that goes with it. So the AI is using the rubrics to direct not only what it's teaching, but also figuring out what the student already knows that's relevant for that learning objective. So it doesn't teach things they already know, it builds on that. So a learner can start, pause, and later resume as they choose. The learner can take the class in any type of device. They could start, say, in a parking lot on their phone where they're waiting for a friend, say. And then when they get home, they can continue on an iPad. And then maybe the next day during a break, they can finish on a computer at work. Doesn't matter. And the LLM can speak and listen in all common languages. Each session of the way we set this up has 3 phases. So here's an analogy that I sometimes find useful to describe it. We start with a teaser video. It's like if you were debating creating a huge garden. It's a lot of work. So you go see a friend who set up such a garden that's in full flower, it's blooming, to get inspiration. So you look around. The purpose is to see what's possible, to get oriented. It's not an overview, it's a motivational thing, the teaser video. The second phase is a knowledge check content delivery. So the knowledge check is like checking what's in the soil, what nutrients are present, how much water is there, and so forth, to figure out what you need to add. So we don't teach them things they already know. We want to fill in and build on what they already know. And then at the end, you want to see if they can do something with this. It's not just about memorizing information. You want to set up a situation and see how well they can use what they've learned. So it's analogous to a trellis where you want to see with all the nutrients in the soil, the water, the sunlight, how well can the plants actually draw on everything. So let me expand on this just a little bit. So phase 1, the teaser video. AI creates a short, less than a minute and a half, usually less than a minute, video that introduces the session as a whole. The video is engaging and stimulating. I wish I had time to give you some examples, but it's interesting. The video motivates the learner by illustrating, showing why the topic is important and relevant. Show, not tell in this case. And then we get to the meat of it, the knowledge check and content delivery. So using the learning objective for that particular session, uploaded resources, what you want them to know, and associated rubrics, which will guide for evaluating and teaching. The LLM assesses the learner's prior knowledge and identifies what they need to learn. The LLM then provides personalized lectures, tutorials, and/or videos to address the learner's needs. So having figured out what they need to learn, fill in the gaps. The LLM adjusts the examples, level, and pace of instruction for the individual learner, personalized. It's dynamic, personalized. And then at the end, application activity. The AI administers an active learning exercise. There's been active learning throughout, but now we're going to use an exercise to assess them. Previously, it was formative. This is now summative, in the sense we'll actually get an assessment of how well they learn. So a debate, role-playing game, analysis, there are dozens of these different active learning exercises. I've written a couple books on this where I lay out summaries of different ways to do active learning, many of them, not all of them, but dozens of them. The exercise requires the learner to use the information that underlies all aspects of the learning objective, not just what was taught in phase 2. So the idea is we figured out what nutrients were already in the soil. So we figured out what they already knew. But now we're going to draw on everything, both what they walked in the room already knowing and what we taught them. We want them to put them together to be able to apply the information, to be able to do something with it. The exercise that we use fits the session learning objective. So we have an AI prompt that helps select from these dozens of different kinds of active learning exercises, the ones that'll fit best. Usually it gives us 3 alternatives and the human picks it out, but it narrows down the range. All exercises draw on the science of learning. So we're using these underlying principles of things like deep processing, deliberate practice, chunking, things like that throughout. Ongoing assessment during active learning, the application activity. The AI uses the rubrics for the learning objective to assess the learner's performance during the active learning exercise thing at the end. If the learner has not mastered aspects of the learning objective, AI provides a directed tutorial followed by additional active learning. Again, at a convenient time and place for the learner. This idea it's asynchronous, but within that, it's very dynamic. It's kind of a dynamic asynchronous. So to summarize, dynamic personalized learning, DPL can substitute for components of traditional classes. So I've been talking about it like it stands alone. That's how we do it. But you can also use it for pre-class work in a flipped classroom to make sure they actually learn the material asynchronously before there's a class discussion. Or you can use it for homework, you can use it for study aid, project-based learning, or supplementary learning. This technique is very broadly applicable. So you might ask, why did we develop software to do this that works alongside the ALM? Why not just feed an LLM directly the learning objective, the rubric, learning resources, and so prompt it? Well, by developing software, it doesn't require the learner to submit a sequence of materials. It's a lot, you have to trust them to do all this, the prompts, learning objective, rubrics, resources. Plus, we can do centralized updating and editing simultaneously for everybody without introducing the opportunity for more error if we ask them to do it for us. Plus, we record a transcript of all the interactions between the learner and the AI. Plus, we reduce hallucinations via something called a RAG, Retrieval Augmented Generation. There's a database in there where we feed in the resources and we tell the AI just to use those resources when it's doing its tutorials and so on. Way reduces hallucinations. And we store and apply teaching-specific guardrails and guidelines. So guardrails are things like don't use obscenity, also stay on topic. So the AI has this built into it, and guidelines like from the science of learning. So that's all built into the software, which makes using the LLM much more efficient than if we just did it directly through putting things into the content window manually by hand. So to summarize, I said at the beginning it was better, faster, and cheaper. It's better because the AI helps us leverage the science of learning to make learning effective and efficient. It's faster, and the AI tailors the content and pace of instruction for each learner. So it's not so slow as to be boring, not so fast as to be frustrating, which means you'd have to do it over again, right at that Goldilocks spot in the inverted U. And it's cheaper. AI cuts the cost of designing, like the videos, delivering, and assessing education dramatically. So I said at the beginning, we can distill most of the active ingredients of the interaction that made classic Greek education, where the ideal learning environment was a log, apparently, with the instructor on one end, the student on the other. Think Plato, Socrates, Aristotle. Very effective. We were able to do a lot of what made that so effective by personalizing this dynamic kind of education with individual students, taking advantage of what LLMs do well and helping them use the science of learning in a way that's extremely effective, and this method scales. So dynamic personalized learning, thank you for your interest. If anybody wants to know more, the article we wrote in this issue goes through this in detail. And of course, I'm happy to interact with any of you via email or Zoom call if you're interested. Thank you very much.
Thank you so much, Stefan, for that powerful opening on dynamic personalized learning. I think we deeply appreciate you joining us live from the US at 8 a.m., a testament to your commitment to developing human potential across time zones. So thanks, Stefan. Now we turn our attention to another exciting perspective, how AI, cognitive science, and ChatGPT come together to unlock learners' potential in English language learning. So please join me in welcoming Louis Gray from the Colegia di Muntinpulla, Philippines. Over to you, Louis.
Thank you, Prof. Azizawalasi. Good evening, everybody. Let me just have my presentation. Good evening. Today, I'm going to share to you a very interesting topic. This is actually a commentary about the intersection between the synergy of artificial intelligence, cognitive science, and ChatGPT. Well, generative artificial intelligence has seeped into the various veins of society, with education not being exempted. In fact, we've got here ChatGPT being the lead because it's one of the, not the most famous generative AI tool. It's a large language model capable of generating human-like text. In fact, it's not only text anymore, but audio, videos, and many more based on prompts. It's so versatile to the extent that many individuals, including students, get to use that in the realm of English language learning? Well, we've got the help in terms of reading to writing to grammar and vocabulary with some interesting results. However, the problem is that despite all these wonderful things, many teachers get to utilize ChatGPT without clear structured framework. So for the students as well. In this paper, I contend that simply chatting with ChatGPT isn't purposeful, and having no plan in that will not lead to something that will put forward impactful learning. Therefore, what I suggest is this. We utilize the power of ChatGPT through some intentionality. And of course, we must not remove the power of cognitive science strategies in this case. Now, there are many cognitive strategies I put forward in the paper. There are 10 actually, but due to the limitation of time, I'll have 5 only. One of which is this, elaboration. This simply refers to the expansion coming from the term itself, explaining, elaborating. For example, if a student is learning present perfect tense, ChatGPT may be helpful there by explaining rules and giving some examples. They may also want to compare that with other tenses and then have more explanations all throughout and then apply that in various contexts. Next is this, generation. And what do you mean by generation? We get to produce responses and not just only to receive it. Most students particularly are into receiving the content coming from what ChatGPT vomit, and therefore, very important that students get to generate as well. How do we do that? After, for example, conditional sentences, ChatGPT may give some examples for that. The type 0 conditional to type 3 conditional. Students must also give some examples, okay? And they may ask ChatGPT to provide queries, and then students will give answers and then ask for feedback and then practice continually until they have mastered the topic at hand. Next is this, dual coding. This simply means the combination of visual and verbal info for stronger learning. Well, this is very powerful because it's not only text, there is also picture that could better fortify learning. For example, a student is learning body parts, they may ask for a diagram for that, and then they may answer, the students may answer them, and from there the interaction occurs. We've got, second to the last, we've got mnemonic devices. I utilize this because I'm a second language learner and I want to really reinforce my learning of some vocabulary words. I utilize that through the power of acronyms. For example, if I want to remember some words, ChatGPT may give some of that examples. And also images are so cogent to understanding a certain vocabulary or an English language phrase. We've got rhymes and songs. ChatGPT can be helpful in that case. Lastly, we've got desirable difficulties. Very important that students do not just copy and paste content. That what we need to understand is though they're using the power of efficiency powered by ChatGPT, they need to really experience the difficulties which are desirable for very potent learning. And it may sound scary, but it's good for any learner. They may ask some challenging prompts and creative scenarios. From there they can get to answer and embrace complexity, so they can boost the engagement. And to end this, I need to put forward a caveat. The benefits are clear. However, it's not a magic bullet. And they may be excessive dependence that may occur, and it's not good. Sometimes ChatGPT and its cousins produce AI hallucinations, as what Prof. Coslin put forward, inaccurate responses, and therefore this necessitates expert English language teachers. So overall, what I want and any teacher wants is we need to establish clear guidelines to ensure that AI supports and that it doesn't replace the teachers. And from there, we can better have a great English language experience. That's all. Thank you.
Right, thank you so much, Louis, for showing us how AI cognitive science can empower English language learning. So just like Professor Stefan's talk, we will hold the questions, if you have any, till the end of everyone's sharing, and then we will engage in a Q&A. Okay, now staying with the theme of technologies for personalized and neurodivergent learning, our next speaker will focus on empowering learners with neurodiverse conditions such as dyslexia and dyscalculia. So please join me in welcoming Dr. Wang Feng Juan from NTU Singapore, who will share a dimensional framework and machine learning approach to support this important work. Over to you, Feng Juan.
Thanks, Adi. Let me share my screen first. Good evening, everyone. I'm Wang Feng Juan from Nanyang Technological University, National Institute of Education in Singapore. So today I'm going to talk about this topic, employing a dimensional framework and machine learning to empower research on dyslexia and dyscalculia. So here is some background information for dyslexia. So if you are unfamiliar with its definition, it's characterized by severe language learning difficulties, whereas the dyscalculia is marked by severe math learning difficulties. So as we all can tell, both of these learning difficulties will significantly impact the academic performance and well-being of school-aged children. So here are some symptoms for the two learning difficulties. We can see there are some overlapping. So this means some children, they may suffering from both learning difficulties. But in the real cases, it's this the complexity of the learning difficulties is so easy as just two overlapping circles. So here are the 9 cases from my PhD studies. Here we can see from this table, so the real 9 cases, they all have impaired mathematics related skills, but for each 9 cases, so there are some different combinations. For example, for case 1 and 2, case 1 and case 8, so they share the normal reading related skills, but the working memory and IQ are impaired. However, for the case 5 and 6, the IQ are normal and working memory are normal. Just reading related abilities and mathematics skills are impaired. For case 2, 4, and 7, so actually all the 4 aspects of the skills are impaired. So these 3 are the most severe cases. For case 3, so his or her reading related skills and working memories are normal. However, his or her IQ is marginally impaired. For case 9, the reading related skills is marginally normal, and the working memory normal. However, the IQ is impaired. So in literature, there are two frameworks to investigate the two learning difficulties. So if you remember the two overlapping circles, it's within categoric framework because it's based on the hypothesis called core deficit hypothesis. So you may heard about the non-persons deficit for the math learning difficulties. You may heard about the phonologic awareness deficit for language learning difficulties. So within this framework, we're trying to recruit very highly selective sample size. For example, children, they must only have the language learning difficulties, or they only have very pure math learning difficulties. So since the hypothesis is just a core deficit, so they only assume that there's only single pathway to explain these learning difficulties, and we are trying to give different groups of children a label, like trying to make them qualitatively different from each other. However, under dimensional framework, as we can tell from the 9 cases, so actually there are many overlapping factors, right? Then it's more complex, and also the many children they share some comorbidity or learning difficulties. So the 9 cases are also inclusive. They can have this kind of learning difficulties, but some of the other skills are normal. So we assume there are different or multiple pathways to explain the learning difficulties. And for these cases, there are actually quantitative differences. They are not quantitatively different from each other. So as we can think, if we investigate the learning difficulties within a dimensional framework, there is no predefined hypothesis, because there are many overlapping factors, so there are many pathways. So if we have a lot of data, then it will be data driven. We just allow the data itself to reveal the shared characteristics among the samples, and also we try to identify the natural grouping or patterns from the data. So that's what machine learning technologies can do. So in my next 2 slides, I will make further explanation. So the first technology we can use is the combination of unsupervised and supervised machine learning. Because from the unsupervised machine learning perspective, it can learn data structure without any predefined patterns, avoid arbitrary cutoffs. For example, for previous research, they trying to investigate within the categoric framework, trying to recruit those children with only math learning difficulties. So usually we will set up a very clear cutoff criteria, like if the children's math performance is under 25% compared to his peers, why 25? Then how about 26, 25.5? So this research in 2018, it showed the behavioral cutoffs may mask the shared neural mechanisms. Of course, every technology has its limitation. If we just use the unsupervised machine learning, it may have a risk of oversimplifying differences between learning difficulties. So the solution is we can try to combine the unsupervised machine learning, which is to discover, and then supervised machine learning, which is to try to validate the conclusions we got from the unsupervised machine learning. So it's called a semi-supervised machine learning for more accurate classification. So in this way, we can capture the complexity of learning difficulties. So the next technology we can use is simulated technology. Under the categoric framework, so we know the sample size is highly selected. So the sample size is very small, and also for the learning disorders, it may have only like 5 to 8% children have. So the sample size for learning difficulties might be a bit small. So for this research in 2021, they simulated 1 million children based on just real data from 47 children with math learning difficulties versus 80 and 95 controls. The conclusion is actually there was no single core deficit identified for machine learning difficulties. Another technology we can use is to trying to create digital twins based on the behavioral data or neural data. So we can try to explore the causal link. For example, for this research, they are trying to test whether the hyperexcitability from the brain caused math learning difficulties. So this we can help us move forward from correlation toward causation. So if we combine the computational neuroscience plus machine learning, we can overcome the small sample size because we know the neuroscience also generate a lot of data. Okay, thank you. That's all from my presentation.
Thank you so much, Fenjen, for the presentation on employing machine learning to support learners with neurodiverse conditions. Now, from the technological to the humanistic, we now shift from Team 1 to Team 2, the arts, identity, and the effective core of human potential. So may I invite our next speaker to share with us a little bit more on how we can optimize human potential by struggling over subjectivity in education through caring for the self. And so with that, may I invite Xiaohan Chow from University College London. Over to you, Xiaohan.
Hello everyone. Can you hear me?
Yes.
Okay, so good evening, everyone. I'm so pleased and honored to be with you together and to share with my research. And my name is Xiaohan. You can also call me Estelle. And I graduated from UCL, major in philosophy of education. So my article, I think is compared to others, is very old, or maybe you can see very ancient, because I'm inspired by Foucault's book, The Hermeneutics of the Subject. So I will trace back to the ancient philosophy to see how can we struggle over subjectivity, and then to help to contribute to the human potential. So you can see the overview here, and we'll cover 5 parts today, from abstract to discussion. And now we come to the first part, abstract. Here is the core focus. So my research draws on Foucault's work to bridge his critique of schools as panoptic institutions and his later emphasis on care of the self. And I think in my article, I propose a multidimensional model of student subjectivity, which is integrating philosophical, psychological, technological perspectives to explore how caring for the self optimize human potential. And I think it's very meaningful because it highlights links between ethical self-care, purposeful living, and sustained growth in educational context. And in the introduction part, first I will introduce Foucault's shift between his early work and his later work. And then I'll propose my questions. So first, I want to share this paragraph that I quoted from Foucault's book, because I think these questions are very fundamental for everyone if we want to care for ourselves, if we want to struggle over subjectivity. And it was very important for my research because it elicits my research question. So I want to read this paragraph for all of you. What should one do with oneself? What work should be carried out on the self? How should one govern oneself by performing actions? In which one is oneself the objective of those actions, the domain in which they are brought to bear, the instrument they exploit, and the subject that acts? So I think it's a very these words or these questions are very thought-provoking for everyone. And here comes to my research questions. First is, how can care of the self mediate the struggle over subjectivity in education? And second, what roles do teacher agency and learning technology play in this process? And last is, can this framework I propose in my article finally optimize human potential? So here comes to the theoretical framework. And my framework, just like Foucault, I trace back to the Greek philosophy to see this concept, care of the self, and to let everyone to see how Foucault interpret this concept and the subjectivity, and see what's the meaning or what's the definition of subjectivity and the care of the self and the relationship between them. I think it's very important for us to figure out the meaning of these concepts and the relationship between them. Now we come to Foucault's key claim on care of the self. And I think Foucault's claim, he has like four assertions of care of the self. First is care of the self is very polaric, or we can say polaric, yeah. It's not egoism or non-egoism. It's a relational ethical practice for Foucault. And the second is if you want to learn how to care of yourself, you must know yourself. So care of yourself is based on knowing yourself. If you don't know yourself, then you don't know how to care yourself. And the third definition is care of the self is very dynamic. It is not just an attitude, but also a practice. It shapes how individuals relate to other, relate to self and the world. And the last is care of the self is the practice of the self. It helps to shape subjectivity. So I think these claims can help us to know what is care of the self and the relationship between care of the self and the subjectivity. Now we come to subjectivity. What is subjectivity? And I think in my research, subjectivity is not a contrast to objectivity. It's not just facts versus feelings. It's a dynamic, reflexive process that can navigate one's understanding of the world, sense of self, and values. So I think care of the self is the condition to obtain subjectivity. You can also see the dialectical tension between them because care of the self fosters subjective freedom. It does help, but you should know that no one can got complete freedom, or no one can be 100% free because you are in relationships since you were born. And now is the reciprocal relationship between subjectivity and care of the self. And you can see they are like the positive circle, and they are very helpful for each other, because care for the self is a necessary condition for subjectivity, and subjectivity can reinforce self-care practice. So what can we do during schooling education to help students care of themselves and to struggle over subjectivity? And I think there are 3 factors that can help. The first is teacher agency, and then students change. Last is the technology of the self, or we can see educational technology. First, I want to talk about teacher, because teacher is a very important role in education. You go to a school, if you go to a school, you can imagine that there's a school without teachers, right? So teacher is very important. And in Foucault's book, teacher also has a very high position, and Foucault called teachers master. So we can see that teacher agency as a mediating force can help students to care for themselves. And but there are also some conditions for a teacher to exercise their agency. So there are 2 aspects in my article, is from external and internal aspects to analyze that the conditions for teacher to use their agency. Another factor that is students change. It's a very interesting topic because if one begins to care for themselves, there must be some changes happening. So I think the process of caring for yourself and for struggling over subjectivity is the process of changing. It's just like Foucault said that changing or conversion is to turn around towards the self by turning away from external things. You begin to turn like inside from you and to think about what you want. You begin to care about yourself. You begin to take yourself as a subject. So that's very important. But there are also some challenges for students, in schools to care for themselves, such as there are structural limits, developmental traits, and skill gaps, etc. And the last factor is that I think recently most talk about is technology. Educational technology do help students to care for themselves, like Professor Coslin said, yeah, and we have different types of technology, such as AI-driven adaptive system that can enable self-monitoring, and the collaborative platform can foster relational subjectivity. So it do help, and also like Foucault talk about in his book, The Technology of the Self. So he also admit that technology is very helpful for students to struggle over subjectivity and to help them to maximize their potential. Yeah. Now we come to the conclusion, and there are 3 key findings of my research. And first, I want to know that care of the self is very critical for people. But we must realize that care of the self is a privilege. It's not universal, because there are so many people, they are facing survival barriers, they are surviving. So it's limited by social or economic inequalities. Yeah. And the second is contemporary education often treat students as tools rather than goals. So maybe the neoliberal education will reduce students to commodities, but care of the self can offer resistance, thus help people to maximize their potential. And the last findings, I think, is we know what are helpful. First is teachers. They are very significant in education, in helping students, because they are the primary facilitators. And then is technology. serving as auxiliary tools are also very significant to offer personalized support. And here we can see the Foucault's legacy for us. Because for me, Foucault's shift from critiquing power to advocating self-care just shows the education's potential to foster transformative subjectivity. And then he also said that education as a protected environment for us, for human, because we can learn knowledge. And knowledge is a means of surviving by understanding ourselves, by understanding others and the world. Okay, the last is the model in my research. I think it's very clear for everyone to see these concepts that I put up in my article and the different and the relationships between them. Yeah, so thank you for listening. That's all. If you have any questions, please feel free to ask. Thank you. Thank you for everyone.
Thank you so much, Xiaohan. An important provocation on subjectivity and caring for the self as a pathway to human potential. All right, from technologies to some of the effective aspects of human potential, we now continue under our next theme, psychosocial scaffolds for learning and thriving, with a presentation by Dr. Imelda Callion from the National Institute of Education, Singapore. Her talk is titled Unveiling Archetypes of Adolescent Social Functioning, a latent profile analysis of social adaptation and integration. Over to you, Imelda.
Thanks very much, Azzy. A very good evening, everyone. Allow me to start with a quote from Charles Darwin, which inspired our article. According to him, it is not the strongest of the species that survives, nor the most intelligent, but the one most responsive to change. As we navigate a constantly changing and interconnected world, social adaptation and integration are two constructs that we consider as essential for surviving and thriving. Okay, so moving on to slide 2, we conceptualize social adaptation as comprising social self-efficacy and openness to diversity. So based on social learning theory of Bandura, individuals who are confident in connecting with others and handling interpersonal issues are more likely to adapt successfully in social challenges and other challenges in their lives. This basically reflects social self-efficacy, which pertains to the belief that in one's ability to engage effectively in social interactions and build close relationships. Moreover, we also use the adaptationist framework, which is grounded on the promotion of harmony in culturally diverse settings. In our study, we considered openness to diversity as a construct that reflects one's awareness and appreciation of both similarities and differences between the self and others, as well as comfort in interacting with others who are different from the self. So for social integration, we conceive this construct as comprising sense of belonging and emotional isolation. So we define social integration as analogous to social embeddedness that supports participation, social support, and psychosocial functioning. In line with the need to belong hypothesis by Baumeister and Leary, social integration can be construed as reflecting a sense of belonging, which is pertaining to feeling of being connected, accepted, and included. Emotional isolation or loneliness is about lacking deep connections and having no emotional or lacking deep connection with others. Okay, so these are the ones who are likely to be at risk of depression. Okay, so based on this conceptualization, we have conducted our study and formulated our hypothesis, which is presented in slide 3. Okay, so as I mentioned, with social adaptation and social integration, construct as focal variables, we utilize a person-focused approach to deepen our understanding of adolescents' attitudes and abilities to adapt to social situations, as well as their social emotional embeddedness. Okay, so we use these variables to identify favorable conditions, configurations, as well as groups requiring support. Okay, we also hope that through our analysis, we are able to identify specific variables or areas for such groups that need further attention. So for keeping this in mind, our study aimed to investigate how social adaptation and integration profiles varied among large sample of adolescents from a multicultural context, which is Singapore, and how these profiles are associated with key outcomes such as intrinsic motivation, well-being, depressive symptoms, and school resilience. Okay, so for our methodology, we have it in slide 4. So this study is part of a larger study. We call it the peer power study that aim to examine the nature of students' peer relationships and how such relationships are linked to well-being and school outcomes. So this article is based on data collected from a convenient sample of about 1,900 secondary 4 students or grade 10. Okay, they are attending, at the time of the study, they were attending 10 government secondary schools in Singapore. So the outcomes were assessed using an online survey involving the focal variables. So for our analytical approach, we conducted a latent profile analysis. Okay, so we evaluated profile models using standard fit indices, as you could see here. Okay, we also utilize the bootstrap likelihood ratio test, BLRT, and Low-Mendel-Rubin likelihood ratio test to identify, to compare different profile models. Okay, so we also took note of entropy values. We evaluated them. Higher values are the ones representing better classification accuracy. Our decision on identifying the final model was based on the interpretability of the patterns and profiles as well as in addition to all those indices that I had mentioned. Okay, after identifying the best fitting model, we also did manual BCH method to compare the differences between covariates and distal outcomes, the ones I mentioned like motivation, resilience. Okay, we compared them across the different clusters. Okay, so we also calculated effect sizes based on using Cohen's d. Okay, so moving on to the results as shown in slide 5. So we have identified 4 distinctive clusters. We have cluster 1, which is what we labeled as the struggling isolates. So that is the one with the square. Okay, so we could see here that they are low on all dimensions of all positive dimensions of what was the first one? Social integration, and the other one is social adaptation. Okay, so the negative dimension of social integration, which is emotional isolation, they are high on that. Okay, so cluster 2 is what we labeled as the detached social engagers. So that is the one with the diamond figure here. So they have moderate levels of openness to diversity, social efficacy, and sense of belonging, and also a moderate level of emotional isolation. The third cluster, the selective social engagers, they are low on openness to diversity, but resembles the touch social engagers in relation to the other dimensions or variables. Okay, so the best configuration, most adaptive configuration or cluster is what we call the connected tribers. So you could see here that they are high on openness to diversity, social efficacy, and sense of belonging, and low on emotional isolation. When we look at their outcomes, the distal outcomes, when we compare the distal outcomes across these 4 clusters, we noted that higher clusters okay, tend to have better psychosocial functioning, such as psychological well-being, life satisfaction, motivation, and resilience. They tend to be low on depressive symptoms. However, we noted that the detached social engagers, okay, they tend to be higher, cluster 2. They tend to be higher on psychological well-being, intrinsic motivation, and school resilience compared to the selective social engagers. These clusters did not differ in relation to life satisfaction and depressive symptoms. So moving on to slide 6 for our summary and conclusion. So basically, we have identified 4 archetypal clusters of adolescents. We are able to provide a fine-grained perspective on the varied ways by which social adaptations and social integration manifests among a large samples of students in Singapore. Okay, so we noted 3 particular clusters that need more attention. Firstly, we have the struggling isolates. This particular group need a multi-pronged approach when it comes to providing support in order for them to improve and to achieve the potential or improve, enhance their potential for thriving. Okay, so we need to support them in relation to social efficacy by teaching them social skills, and also providing peer support bodies or mentors which could serve as or who could serve as their role models. In order to improve their openness to diversity, we believe that it is important for them to be provided with structured opportunities to experience positive intergroup interactions, like mixing them with students of different abilities, different cultures, immerse them in environments that acknowledge and celebrate diversity. This is particularly important in Singapore setting. We hope that for the selective and detached social engagers, we hope that they can be taught skills to relate with others more deeply. So basically, they are okay when it comes to social, their perceived ability to interact with others. However, it appears like they need more attention when it comes to building more deep friendships and developing trust, because they have higher values in relation to loneliness, social emotional loneliness. For the other group is for the selective social engagers, cluster 3. We believe that they need more support in relation to developing positive attitudes towards outgroup members. Okay, so just like what I have mentioned earlier in supporting the struggling isolates. Okay, so hopefully these insights from this study can be utilized by educators in framing a more nuanced support initiative for adolescents to optimize their potential and help them to survive, adapt, and thrive in an increasingly diverse and changing social ecosystem. A potential follow-up for our study would be on examining the mechanisms that link the social adaptation and social integration with the psychosocial and educational outcomes that we have mentioned. Okay, that's all for my sharing. Thank you very much for your attention.
Thank you so much, Imelda, for that compelling exploration of adolescent social functioning and profiles that can guide more tailored and personalized support. Now, everyone, as we close, we move into our final presentation by Purnima Mondal, which brings us into the mathematics space. Sahowa examines how multimedia-based instruction can reduce math anxiety and enhance problem-solving ability, an important reminder for us that unlocking human potential also means designing learning environments that not only inform but empower. So I hope this is a fitting conclusion to our session as it integrates theory, technology, and emotion in the service of thriving. Over to you, Purnima.
Thank you. I am Purnima Mondal, a scholar, a research scholar of School of Education, Pondicherry University, India. And I am going to present a conceptual paper, Efficacy of Multimedia-Based Instruction on Mathematics Anxiety and Mathematics Problem-Solving Ability. This is the outlines of the presentation, how our study, our paper describes the relationship or influence of multimedia-based instruction on mathematics anxiety and mathematics problem-solving ability. In the overview, the study started from learning and describes multimedia-based instruction, mathematics anxiety, and mathematics problem-solving ability using previous studies or previous different experimental studies. After that, the study developed a model of anxiety using Freud's psyche theory, and after that study find out the indicators of mathematics anxiety using Sarag and one second. Sorry. Sitaras and Sarag study. After that, the study describes about mathematics problem solving ability using Foiler's theory, and after that the study try to make a relationship or influence of multimedia based instruction on mathematics anxiety and mathematics problem solving ability, and after that the study did conclusion. In overview, the study discuss the using previous study that learning is a schema creation process involving assimilation and accommodation and adaptation process according to Piaget, and the learning is also a electrical signal or it is a action potential of the neurons of memory. It is describing by Hinton, and it is by Echinaho. They are describing that emotion, the learning. It is that emotion is the foundation for all types of learning. Hinton also in their study they describes that in their study mind, brain and education, they describes that in our brain whenever we are learning something particular area, in particular area the neuron is doing action, and there some signal or action potential is working, and for particular activity in particular area of the memory it is working, and that for the neuron which is working for creation of emotion, that is controlling the others neurons activity. So emotion is the very important for learning in and for any thinking process. According to AI also, anxiety is the primary negative emotion. If the experience becomes negative and it creates the negative emotions, and that demotivates to learning and it hampers to thinking also. And this factor means this anxiety significantly impairs the learner's performance. It is not it is different previous studies also it is identified that this mathematics and anxiety it is a very significant factor that negatively impacts not only their performance, it is their problem solving ability, and it is controlling their state of mind also. In this scenario, that multimedia based instruction, we know that teaching learning is a very important process in our education system, and the teaching process is shaping the learner's development, and it is guiding to develop them. So for that the teaching process always searching for new technologies to represent the information to learners. So in this case the multimedia has come a very important pedagogical tool, and it represents the information virtually into the classroom, and it what it becomes when the information it is representing into the classroom situation from the known environment of the student, then the students becoming emotional and they are going to engage actively. So in this scenario, the multimedia has becomes very important tool to to make students more active into the classroom. Meyer also gives Meyer in many studies they gives uh, outlines, they gives theory, they gives principles to develop content, how to represent the information using multimedia based instruction, such that the students can use multiple sense organs in the classroom and they can learn actively. Lang and others also, they did experiments using computer-based instruction, and they found that the content presentation of biology using computer-based instruction, it improves the students' recallability and comprehension ability. Kasha and others, they did experiment in secondary school and they shows that the multimedia instruction enhances students academic achievement. It is also a study on biology. Plus also he did study and he investigated how the multimedia means the using of content using dynamic visual aids and interactive content, how it is doing impact for mathematics class. And their study also found a positive impact of multimedia on students mathematics performance. AI and others also, they explored that virtual reality and uh, gamification of multimedia, it helps to reduce the students anxiety in language development. They used multimedia to present content in the language development to represent the foreign language, and they got positive result for that. Huang and Meyer also, they conducted this multimedia technique in mathematics class and mathematics content. They represent using computer based instruction, and they found that the content mathematics representation using multimedia helps to reduce mathematics anxiety and it improves students problem solving ability. But the study found very few study that how the multimedia is helping on multimedia helping to decrease the students mathematics anxiety, using it is helping to them for their problem solving ability, they are thinking. So the study motivated, the present study motivated from the previous study, and the previous study guided the present study to explore the influence of multimedia based instruction on learners mathematics anxiety and mathematics problem solving ability. The researchers are also conducting the experiment on that paper, but this concept and the pre-test already conducted, and the researcher developed the package also, and the implementation is going on. So for the present study for anxiety processing, the study got concept from psyche theory, where the psyche theory proposes the concept that when the human is doing when human is interacting with environment, their mind is working in three layer. How it is when the human a individual is interacting with the environment, at that time when he is doing action or he is making judgment, he is creating idea, their conscious layer of mind is working at that time for response or action. From this activity of conscious layer, whatever experience is creating and knowledge is creating, that is storing in the another layer, that is subconscious mind, and it whatever the emotions is creating from there, from the action or experience, that is storing in unconscious mind. And if the emotions, the negative emotions creates from that experience or that activity, that is becoming anxiety for a individual. And whenever the individual facing a certain situation, anxiety is coming through their physical expression and emotional expression. They don't know, it is their unknown behavior. It's certain situation it is coming out. So from this theory, this paper gets the 4 types of indicator to measure the anxiety in an individual, and to identify the anxiety that the individual is suffering in anxiety. For mathematics anxiety, Sitoras and Sarayagi, they give some indicators also. And from their study, if we observe that their study also provides some indicator that learner's response is very important indicator, experience is very important indicator, their emotional expression and physical expression, it is also very indicator for mathematics anxiety. So this paper compare this indicator, mathematics indicator, with anxiety indicator, whatever the study gets from psyche theory. So from there the study describes the study gets concept that the indicator, just like a response, previous experience, their physical expression, emotional expression, it is very important indicator. So so for finding out mathematics anxiety for a students, the study can use this concept, and we can the study can use and can measure the mathematics anxiety among students. For mathematics problem solving ability, Barrows in 1986, he defines that students' problem solving ability is the most successful learning outcomes. And for and Woodward and Marcus also, they defines that the problem solving ability is the ability to transform the conceptual and previous knowledge into the similar situation. And here Foila gives, for mathematics, here Foila gives some principles, 4 principles, how a learner should to perform the mathematics, understand the problem, devise a plan, carry out the plan, verify the result. For problem solving, student should to understand the problem clearly. After that, he should to develop or design a equation, or find out the formula based on understanding for the problem. After that, calculate the problem, and if the calculation, after calculation, if the student understand the problem clearly, then verify the result. If the result satisfy the previous conditions, then it is very good, no need to worry. If it is no, then again go first step and check the problem clearly. So from previous studies and from Meyer principles and dual coding theory for teaching learning process, we know that for students development, students problem solving ability, whatever we are talking about, the teaching is the very important process where everything is guiding for a development of a student. So, and here the multimedia is working as a assistant for a teacher. How it is helping for that, Meyer gives on concept on the theory, cognitive theory of multimedia. Whenever students is learning in a multimedia based instruction, how their memory is working, how it is processing the multiple sensory organs involving, and how the information is processing in their mind, and how it is doing impact on their learning domain. So this study combine the Myers cognitive theory of multimedia and dual coding theory of memory, and develops this model how whenever a student is learning in a multimedia based instruction, how it is doing impact on their learning domain, how it is helpful for their experience, how recalling ability, how it is helping for their emotional and motivational development and their performance. For here, the dual coding theory also provides some hypothesis, peg hypothesis. There also they gives a ascending order of presenting students response in a stimulus. When stimulus is presenting by abstract or by content figure, then the students response, how it is increasing, they gives a ordered. Whenever it is abstract form, then it is becoming the very less, and whenever it is abstract concrete abstract, and concrete means the students response and the content representation, whenever it is abstract and concrete form, it is this says is students response is increasing in ascending order. So here the study used the previous studies, and they from there the study finds that whenever a student is learning in multimedia based instruction, then their mathematics learning, it is for mathematics learning, their experience becoming positive, and it is helpful for their recalling, their understanding, their retention, their comprehension. Whenever it is becoming significant for their recalling ability, their comprehension ability, their it is becoming positive experience, then automatically it is helping for their understanding the problem, and it helps them to select formula or to design a equation for the mathematical problem. And whenever they are able to develop a equation, or they are finding formula, and they are going to attach emotionally, they are motivated, then it is automatically they are again and again it is creating interest to perform mathematics problem. And whenever it is creating, it is increasing their interest to solve mathematics problem. It is creating interest towards mathematics problem, then their performance going to be improved. And whenever it is this confidence, the performance improvement, their response, it is coming improvement, so their confidence is also going to be improvement. And based on that, their self concept increasing, and they can check, they can understand, they can more, they can find out the concept more, and they can check the result also. So in the conclusion, the study found that students experience, students action, emotion, motivation, it is these are the most essential components for a effective learning. And it is also very effective component to find out the mathematics anxiety also. Psyche theory also theoretically supports that, and mathematics problem solving ability for according to Foila's theory also indicates that students experience their emotional attachment with problem, their etc. It is very helpful to create interest to for towards mathematics. And the dual coding theory and the cognitive theory of multimedia, the integration of dual coding theory and cognitive theory of multimedia, it is provides a framework that how it is doing impact on students learning theory. So it is the study conclude that it is also important to find out that how multimedia is doing impact on students computational thinking skills, students neural activity when they are learning in multimedia based instruction. Thank you.
Thank you, Purnima, for that thought-provoking conclusion to our session, integrating cognition, technology, and the emotional aspects of learning in the service of human potential. Now, everyone, as we are now slightly, almost 9 minutes over our allocated time, I'll just take maybe 1 to 2 moments to see if there might be any final questions from the audience. Just to highlight that we've already had several insightful questions raised in the Q&A, and we've already had very thoughtful responses from Professor Coslin as well as Professor Louis. And we also saw there were some meaningful comments in the chat about the responsible use of AI. So thank you, Elgin Armis, if you're still with us. Anyone has any questions that they would want to direct to any of our speaker? Calling once, twice. Okay, no worries. So, just in case you might have any further questions, feel free to contact our speakers directly. Their email addresses are included in the special issue manuscripts, and their manuscripts are all up online. And it's really accessible, at least for this month. All right, so with that, on behalf of the organizing team and our special issue co-editor, Professor Stephen Coslin, I would like to thank everyone for staying with us through this rich and slightly extended session. I wish you a meaningful rest of the day, night, or week, wherever in the world you may be. Goodbye, everyone.